You just realized your business needed to hire someone yesterday. How can you find amazing candidates fast? Easy. Just use Indeed. Stop struggling to get your job post seen on other job sites. With Indeed sponsored jobs, your post jumps to the top of the page for your relevant candidates, so you can reach the people you want faster. According to Indeed data, sponsored jobs posted directly on Indeed have 45% more applications than non-sponsored jobs. Don't wait any longer. Speed up your hiring right now with Indeed. And listeners of this show will get a $75 sponsored job credit to get your jobs more visibility at Indeed.com/PODKATZ12. Just go to Indeed.com/PODKATZ12 right now and support our show by saying you heard about Indeed on this podcast. Terms and conditions apply. Hiring? Indeed is all you need.
This is SpaceTime, Series 28, Episode 23, for broadcast on the 21st of February 2025. Coming up on SpaceTime, was Snowball Earth a global event? Blue Origin experiences a parachute failure during a lunar gravity mission. And have you ever wondered why the moon looks so much bigger when it's near the horizon? All that and more coming up on SpaceTime.
Welcome to SpaceTime with Stuart Gary.
Geologists have uncovered strong evidence that massive glaciers covered the Earth all the way from the poles down to the equator hundreds of millions of years ago. The findings, reported in the Proceedings of the National Academy of Sciences, supports the long-standing hypothesis known as Snowball Earth. It suggests that from about 720 to 635 million years ago, and for reasons that are still unclear, a runaway chain of events radically altered the planet's climate. Temperatures plummeted, and ice sheets that may have been several kilometres thick crept over every centimetre of the planet's surface. The study's lead author, Liam Courtney Davies from the University of Colorado Boulder, says these findings present the first physical evidence that Snowball Earth really did reach the heart of continents at the equator. To reach their conclusions, the authors looked at the Front Range of Colorado's Rocky Mountains. Courtney Davies says a series of rocks they nicknamed the Tava Sandstones hold clues about this frigid period in Earth's past. The authors used a dating technique called laser ablation mass spectrometry. It zaps minerals with lasers in order to release some of the atoms inside. They showed that these rocks had been forced underground between 690 and 660 million years ago, in all likelihood due to the weight of the huge glaciers pressing down from above. Courtney Davies says the research will help scientists better understand a critical phase not just in the planet's geological history, but also in the history of life on Earth as well. See, the first multicellular organisms may have emerged in oceans immediately after Snowball Earth thawed. He says if you have the climate evolving, you have life evolving with it, and all these things were happening during the Snowball Earth upheaval. The term Snowball Earth actually dates back to a paper published in 1992. But despite decades of research, scientists are yet to agree whether the entire globe actually froze over. For example, geologists have discovered the fingerprints of thick ice from this time period along ancient coastal areas, but not within the interior of continents close to the equator. And this is where Colorado enters the picture. At that time, Colorado didn't sit in the northern latitudes where it does today. Instead, it rested over the equator as a landlocked segment of an ancient supercontinent. So if glaciers formed there, scientists believe they could have formed anywhere. And it's the search for that missing piece of the puzzle which brought Courtney Davies and colleagues to the Tava Sandstones. Today, these features poke up through the ground at several locations along Colorado's Front Range, most notably around Pikes Peak. Now, to the untrained eye, they might seem like ordinary-looking yellowish-brown rocks, running in vertical bands between a centimetre and several metres wide. But for geologists, these features have an unusual history. They likely began as horizontal sands on the surface of Colorado sometime in the past. Courtney Davies says forces then pushed them underground, like claws digging into the Earth's crust. They became classical geological features known as injectites that often form below ice sheets, including in modern-day Antarctica. The authors wanted to find out if the Tava Sandstones were also connected to ice sheets. To do that, they first calculated the age of mineral veins that were slicing through these features. They collected tiny samples of the minerals, which were rich in iron oxide, essentially rust, and then hit them with a laser. In the process, the minerals released small quantities of uranium. Now, because uranium decays into lead at a set rate, the authors could use that as a sort of atomic time marker to determine the age of the rocks. And the findings suggest that the Tava sandstone had been pushed underground at the time of Snowball Earth. It means that at that time, thick ice sheets formed over Colorado, exposing the sands to intense pressure. Eventually, and with nowhere else to go, they pushed down into the bedrock below. This is space-time. Still to come, Blue Origin experiences a parachute failure during its lunar gravity mission, and have you ever wondered why the moon always looks bigger when it's near the horizon? All that and more still to come on Space-Time. Blue Origin's new Shepards experienced a malfunction during an unmanned suborbital flight for NASA designed to simulate lunar gravity. One of the capsule's 3 parachutes failed to fully open during its descent back to Earth. Mission managers stressed the capsule was designed to land safely with just 2 parachutes, but they're investigating the issue. The NS-29 mission blasted off from its West Texas launch pad with the new Shepard booster performing nominally.
5, 4, commanded to start, 2, 1, and liftoff.
Shepard has cleared the tower, heading to space. All right, we've hit MECO, main engine cutoff. Shortly here, we'll see separation. The 0G indicator means that we have reached separation of the 2 vehicles, and now the crew capsule and the booster are now coasting to their apogees simultaneously.
After deploying the capsule, the reusable booster made a successful vertical touchdown back on its landing pad 7 minutes after launch.
Descending, the booster is nearing the ground right now. Those air brakes have deployed, which is really cutting the booster's velocity down. All right, there's engine relight and touchdown.
Meanwhile, the capsule continued skywards towards its apogee just over 100 kilometers above the ground. It then began returning to Earth. But as it descended towards the West Texas desert, only 2 of its 3 parachutes fully opened. The third finally unfurled just before landing.
There's the drogue deployment.
And there you see the main parachutes being pulled out by those drogues.
Beautiful.
Beautiful. The parachutes have a slightly new design.
One of those is lagging on its inflation, but that's all right. We've designed the system to have backups to the backups. This system can safely land with fewer than 3 parachutes. So we're going to continue following this as it approaches the West Texas desert for the capsule descent. That's the correct expected descent speed for the capsule after the parachutes have deployed, right about 16 miles an hour.
Yeah, now as we descend under parachutes, now they are essential for providing a gentle touchdown of our capsule, but many backup systems. One of the nominal systems we use for touchdown is our retro thrust system that might kick up a little bit of dust.
And that third chute looks like it has now inflated, which is great. And touchdown, all right.
Beautiful touchdown of the capsule today on our 29th mission here. Incredible to see. Now our capsule recovery team is currently driving out in a convoy. They're going to meet the capsule. They're going to safe the vehicle and open the hatch and extract some of the payloads today.
The mission was carrying 16 payloads inside the capsule, plus 1 mounted externally. All were designed to test in simulated lunar gravity during the flight. These include packages designed to test in situ resource utilization, performing construction and excavation on the lunar surface. There was the Lunar G combustion investigation package, designed to understand material flammability on the lunar surface compared to Earth, measuring flame propagation directly during the flight. Other experiments included instruments to detect subsurface water, instruments to look at dust mitigation, studies looking at flow physics and phase changes in lunar gravity, advanced habitation systems, sensors and instrumentation performance, spacecraft avionics, and entry, descent and landing systems. The payloads were able to experience 2 minutes of lunar gravity, simulated thanks to the capsule's new reaction control system, rotating the module at a rate of 11 revolutions per minute. That spin was enough to simulate 1/6 Earth's gravity, which is about the same as lunar gravity. Previously, the moon's gravity could only be simulated for a few seconds at a time, usually using a centrifuge drop tower or for 20 seconds on board a parabolic jet flight. This is Space-Time. Still to come, have you ever wondered why the moon always looks bigger when it's on the horizon? And later in the science report, a new study suggests that just like cats, wolves may have actually domesticated themselves. All that and more still to come on SpaceTime. Have you ever wondered why the moon always looks bigger when it's near the horizon? In reality, we know it's not. But that's not the impression it gives, and we call that the moon illusion. It's actually a trick which your mind plays on you because when it's high up in the sky, there's nothing to compare it to, so it looks smaller. In fact, photographs have proven that the moon is the same size whether it's near the horizon or whether it's high in the sky. But still, that's not what you perceive with your eyes. It's simply an illusion, rooted in the way one's brain processes visual information. Even though people have been observing it for thousands of years, there's still not a satisfying scientific explanation for exactly why we see the moon the way we do. Go out on any night of the full moon, find a good spot, and just watch it rise or set. It's always a breathtaking experience. And it's always fascinating how when we observe the moon near the horizon, it looks huge, whether it's peeking over the shoulder of a distant mountain, rising out of the sea, hovering behind a cityscape of buildings, or simply looming over a thicket of trees. But of course, in reality, it's all in your head. The moon's seeming bigness is simply an illusion rather than any sort of effect of our atmosphere or some other type of physics. And if you want to, you can prove it for yourself in a variety of ways. Just hold up your outstretched index finger next to the moon. For most people, you'll find your fingernail and the moon are about the same size. So when you look at it high in the sky, and then you look at it when it's near the horizon, you'll find its diameter hasn't changed. Another way to size check the moon is to take a photo when it's near the horizon, and then another when it's high in the sky. So if you kept your camera zoom settings the same, you'll find that the moon's the same width side to side in both images. In fact, it may actually appear a little bit squashed in the vertical direction when it's near the horizon. That's the result of the atmosphere acting like a weak lens. But there is one notable way in which the moon's appearance is actually different when it's low in the sky. See, it tends to have a more yellow or orange hue compared to when it's high overhead. This happens because when it's on the horizon, the moon's light's travelling a longer distance through the atmosphere. Now, as this light travels further, more of the shorter, bluer wavelengths of the light are scattered away. It's called Rayleigh scattering, and that leaves more of the longer, redder wavelengths to reach your eye. Dust and pollution can also deepen the reddish colour. So, as to our original question, why the moon looks big on the horizon, well, we don't know. In general, the proposed explanations have to do with a couple of key elements of how humans perceive the world around them, how the human brain perceives the size of objects that are near and further away, and how far away we expect objects to be when they're near the horizon. It seems our brains can't comprehend that the moon's distance doesn't change that much no matter where it is in the sky on a given night. And there's also something about the objects in the foreground of your lunar view that play a role. Perhaps trees, mountains and buildings help trick your brain into thinking the moon's both closer and bigger than it really is. There was an effect discovered about a century ago called the Ponzo illusion that describes how this works. In this illusion, you have a scene where two lines are converging, like railroad tracks stretching away into the distance. Now on top of these lines, draw two horizontal bars of equal length. Surprisingly, the horizontal bars appear to be different sizes because your brain's hardwired sense of how distance works forces you to perceive it in this way. This effect is related to how forced perspective works in paintings. Trouble is, it's not a perfect explanation. NASA astronauts in orbit also see the moon illusion, and they don't have any foreground objects to act as distance clues, so there's clearly a lot more going on that we simply don't understand. This report from NASA TV.
So why does the moon look larger on the horizon? The short answer is we don't know. We've been talking about this for 2,000 years. Aristotle mentions it. And in our own time, scientists are designing experiments to figure out exactly what's going on, but there's no consensus yet. Here's what we do know. The atmosphere isn't magnifying the moon. If anything, atmospheric refraction squashes it a little bit. And the moon's not closer to us at the horizon. It's about 1.5% farther away. Also, it isn't just the moon. Constellations look huge on the horizon too. One popular idea is that this is a variation on the Ponzo illusion. Everything in our experience seems to shrink as it recedes toward the horizon. I mean, clouds and planes and cars and ships. But the moon doesn't do that. So our minds make up a story to reconcile this inconsistency. Somehow the moon gets bigger when it's at the horizon. That's one popular hypothesis, but there are others. And we're still waiting for the experiment that will convince everyone that we understand this. So why does the moon look larger on the horizon? We don't really know, but scientists are still trying to figure it out.
And in that report from NASA TV, we heard from NASA scientist Ernie Wright. This is Space Time. And time now to take another brief look at some of the other stories making news in science this week with the Science Report. A new study suggests that giving kids with peanut allergies a small amount of peanut butter, up to say a tablespoon a day, can help reduce their peanut sensitivity. The findings, reported in the New England Journal of Medicine, are based on a trial of 73 children aged between 4 and 14 years who were allergic to peanuts but could tolerate up to 143 milligrams of peanut protein, about half a peanut, at the start of the trial. They found that slowly building up their peanut exposure using store-bought peanut butter was effective in raising their ability to eat peanuts. However, the authors stressed not to try this at home without proper medical supervision and only after consulting your doctor. US surgeons say a gene-edited pig kidney that was transplanted into a 62-year-old man who was dependent on dialysis began functioning immediately. A report in the New England Journal of Medicine says the kidney, which had undergone 69 gene edits to reduce the chances of rejection, promptly and progressively began cutting his creatine levels, which is a measure of kidney function. However, despite the gene edits, the man experienced symptoms of rejection 8 days after the transplant. Drugs that further suppressed the man's immune system put a stop to this, but despite the kidneys continuing to function, the man died 52 days after the transplant. Later, an autopsy revealed no signs of kidney rejection in his body. But the autopsy also revealed severe heart disease and scarring, and that may have been the reason why he died. It's long been suggested that humans picked out more docile wolves and bred them, leading to the development of the domesticated dog. But a new study reported in the Journal of Proceedings of the Royal Society B suggests that, like cats, wolves may actually have domesticated themselves. The researchers used computer simulations to show that friendlier wolves that tolerated humans would have had better access to human food scraps and thrived naturally, leading to tamer wolves and eventually domesticated dogs as they bred together. Now, this theory's been suggested before, but critics have always argued it would take too long given to how quickly we think wolves turned into domesticated dogs. However, this new study's authors say their simulations show that self-domestication could have happened quite quickly, certainly quickly enough to have played a major role in the evolution of wolves into man's best friend. Well, we've all heard of the infamous Devil's Triangle between Bermuda, South Florida and Puerto Rico. The place where, according to the myth, aircraft and ships are said to mysteriously disappear. Of course, in reality, the true loss rates there are no greater than anywhere else with similar traffic levels and weather conditions. Well, now there's a new place called the Great Lakes Triangle. Since the 1990s, America's Great Lakes have been rumoured to have their own mysterious cursed triangle in Lake Michigan between Benton Harbor, Manitowoc and Ludington. Tim Mendham from Australian Skeptics says there is no mystery about the Great Lakes Triangle. Researchers have known for years where most of the shipwrecks are located and why the vessels went down. Though he does admit some 225 are mysteriously still missing.
Yeah, there's a triangle everywhere, apparently, where mysterious things happen. Obviously, Bermuda Triangle, there's an Alaska Triangle, there's a Devil's Sea Triangle off Japan. You'll probably find triangles that are popping up all over the place. Triangles are a very convenient shape. All you need is 3 places and you've got a triangle. But this story about the Lake Michigan Triangle or the Great Lakes Triangle up in the North US, southern Canada, hasn't been around that long. The story goes that it's an area where ships mysteriously disappear appear, and never found no reason for it. And started off in 1975, apparently, with a newspaper article that was pretty much a joke. At that time, people referred to the Michigan Triangle, and then a year later, there was a book came out that didn't sell quite as well as the Bermuda Triangle books, but it was around, and it sort of disappeared a bit, and then it sort of has come back again, often promoted by tour guides who like to sort of race in these sort of interesting situations of all these ships having disappeared in the Great Lakes area. Unfortunately, the people who actually do research the Great Lakes and who follow every ship that's ever been in the area, and they've been doing this since 1812, so that's like 200 years of knowing where they went and what happened to them, etc., and when they stopped operating, etc. And they say of all the thousands of ships on the Great Lake or boats, and all the collecting of shipwreck information, there's only a few which they think are still missing, which might have been collisions or storms or whatever. The vast majority of those are not actually in the triangle, which is common with all these triangles. The Bermuda Triangle proponents claim all sorts of ships going down, often didn't go down anywhere near the Bermuda Triangle. But it's a romantic myth, and it sort of sticks around for a long time, and despite the fact that it's been debunked over and over again, it has resurgences, and everybody wants their publicity.
That's Tim Mendham from Australian Skeptics. That's the show for now. SpaceTime is available every Monday, Wednesday and Friday through Apple Podcasts, iTunes, Stitcher, Google Podcast, Pocket Casts, Spotify, Acast, Amazon Music, Bytes.com, SoundCloud, YouTube, your favourite podcast download provider, and from spacetimewithstuartgary.com. SpaceTime's also broadcast through the National Science Foundation on Science Zone Radio and on both iHeartRadio and TuneIn Radio. And you can help to support our show by visiting the SpaceTime store for a range of promotional merchandising goodies. Or by becoming a SpaceTime patron, which gives you access to triple-episode commercial-free versions of the show, as well as lots of bonus audio content which doesn't go to air, access to our exclusive Facebook group, and other rewards. Just go to spacetimewithstuartgary.com for full details.
You've been listening to SpaceTime with Stuart Gary. This has been another quality podcast production from Bytes.com.